We've seen second powers and third powers now. The next logical step is to take a look at fourth powers. As it turns out, fourth powers are not very hard as long as you remember that the square root of x to the fourth is x squared. We can actually just use the difference of squares twice, and that will take care of it. The only thing we have to keep in mind is that sometimes we'll have the sum of two squares, sometimes we'll have the difference of two squares. We're going to need to figure out which one we actually factor when. Now, if you'll remember, the sum of two squares never factors, so you just have to keep that in mind as we go. For example 1, I have a to the fourth minus 16. The first time I employ the difference of squares, this will be a squared, this will be 4. We take the square roots of both. So I get a squared plus 4 and a squared minus 4. As I said, one of these factors and one doesn't. That's prime because that is the sum of two squares, so we're going to leave it. This does factor though. So I'm going to leave my prime factor where it is, a squared plus 4. Then I'm going to factor this difference of squares into a plus 2 times a minus 2. Every single difference of fourth powers has this exact form. So for example 2, the square root of 81x to the fourth is 9x squared. The square root of 256 is 16. So if I use the difference of fourth powers, well, if I start with the difference of squares, I'll have 9x squared minus 16 times 9x squared plus 16. Remember, this factors, the difference factors, the sum doesn't. So again, I'll just write the sum, and then I'll factor the difference of squares into 3x plus 4 times 3x minus 4. And that's it. Just remember, don't factor the sum of two squares, do factor the difference of two squares.